Here, let me turn down this beeping so I don't have to sit here and listen to that too. There. All right. So, how's your A plus coming? A plus.
Good.
Yeah?
Good.
Yeah? Practice will make you pretty good on those, and that's all it is, just a question of practice. So, today, let's do some more algebra. There's some, I want you to simplify this for me. What's this equal to? Combine like terms. How many x's do we have in sum?
7 x's.
Hold on. We got a plus 5, minus 2.
3 x's.
Okay, so we have 3 x's. How many y's?
1 y.
Correct. All right. Let's go now to multiplying.
Alright.
All right. Have they taught you how to do this by a method called FOIL?
What?
Have they taught you FOIL?
No.
Okay, well, I don't know if they still teach FOIL or not. Most places do. I prefer something called ET. Okay? ET. What that means is every term has to be multiplied by every other term. I have to start, multiply that times that. And then I take that same term and multiply that times that. Then I go to the next term and I multiply that times that. And then finally I go to the last term and multiply that times that. And then I add all 4 things together. Okay? The reason they came up with the word FOIL, I'll give it to you just in case you didn't get it, is that's the first arrow that I drew, was from here to there. And then I did the outside terms, that one and that one. And then I did the inside, which is this one times this one, and then finally I did the last, which was my 3y times my 5y. So that's why they came up with this acronym FOIL. Now, the problem with FOIL is it works fine as long as you have 2 terms times 2 terms. Where it doesn't work so good is when you have 3 terms times 2 terms. And that's coming. But every term times every term actually handles all cases. So it's more robust. So let's multiply these together. What's the first? I'm going to write the answer down below here because I don't have much room to go horizontally. But what?
So when I get the answer, is it like?
Well, what's the result of that times that? Let's start there.
Alright, that's going to be 8x.
8x squared.
8x squared.
Hold on. My thing is acting up again. In other words, I multiply the 2 numbers and I multiply the 2 letters. Now, if I can multiply the letters, if I can combine it, I'll do so. In other words, x times x, I can make x squared. Now, what do I get when I multiply 2x times minus 5y? In other words, when I do, what are the two outside terms?
I got negative xy.
Negative 10. Don't forget to multiply the numbers. In other words, you have to multiply the 2 times the negative 5, which gives you negative 10. And then you can't combine the x and the y, so we leave it as x times y. Okay, what's the next term?
The next term is 12yx.
Make sure you put the sign on it. In other words, since these all have to be added together, you can't omit the sign, the plus sign. So it is 12, and I'm going to leave it the same way. I could write it yx. There's no difference between yx and xy. It's just that once I started writing it xy, I'm going to keep writing it that way. Little reminder that I've got the same things. And finally, what's the last term? This one times that one.
Negative 15y.
Y squared. Remember, when you multiply y times y, you can combine that into a y squared. Let's talk about that for a moment. If I multiply x cubed times x to the fourth, I'm going to add those exponents, and I can write that as x to the seventh. So whenever I'm multiplying something that's the same, in this case it would be x, I can combine them. But if I multiply x cubed times y to the fourth, I can't combine those. I don't have the same base. So my answer is just the same thing as I started with. X cubed times y to the fourth without the multiplication sign. You know, multiplying is implied as long as those letters are next to one another. So, all right, so we're not quite done here yet. So the last step after foiling these two things is to combine like terms. How many x squareds do we have in sum?
We only have one x squared.
Well, we have 8. I mean, I knew what you meant, but we have 8. We have to put the coefficient. And then how many of these do we have?
2xy.
So it's a plus 2xy. And then finally, how many y squareds do we have?
Negative 15.
All right. That's multiplying. Now, don't really need to know how to divide. So let's not go there. Let's pick up with where we left off before. Let's talk factoring. Okay? Because now you know how to add polynomials, you know how to subtract polynomials, you know how to multiply polynomials. Let's learn factoring. If I gave you the following. Can you find the greatest common factor for those two expressions? That's the step one of factoring, is talking about greatest common factor.
That'd be 8.
No, what we mean is there a number or a number and letter combination? Well, let's talk about it without the letters for a moment. If I said, what's the greatest common factor here? It's 2.
Oh.
And what I need for that greatest common factor to be able to divide into both terms evenly. I can divide 2 into both terms evenly. Notice that I cannot divide 4 into the first term because I get a half. In other words, when I say divide it evenly, I mean I got to come up with an integer. Okay, well, if I go ahead and put an x squared there and an x there, I can still factor out a 2, but I can also factor out an x. And what's left over is whatever I get when I divide both of those terms by my greatest common factor. Well, what's this give me? That's what I'm going to write right there.
It's going to give you 1x?
Yeah. Just x. Don't need the 1, don't need the plus sign. However, what's this give you?
Gives you 2x squared?
No, we're dividing now. When you divide, you subtract exponents.
Yeah, sorry. It's going to be 1x.
Just 2. Plus 2. Okay, now, when we're done, let's make sure we multiply everything back together again to make sure that it is what we started with. Multiply these two things together, and it's just a question of multiplying this by, in other words, ET. We're going to multiply every term by every term. Well, when we do that, 2x times x is 2x squared, and 2x times 2 is plus 4x. So we got the same thing. And you always want to do that check until you're really comfortable with factoring. Factoring is basically division. We're taking this polynomial and we're splitting it up into one thing times another thing.
Yeah, that makes sense.
Okay. So that's the first step of factoring, is if you can find a greatest common factor, then you do it. However, what if I give you something that looks like this? Is there a greatest common factor for this?
I don't think so.
No, I can't divide 2 into either of these two terms, and I can't divide x into the 2. So there's no way to find a greatest common factor with this. But this is the standard quadratic that we are usually faced with. And what this is the result of two linear terms being multiplied together. In other words, this is x minus 2 times x plus 1. And if you FOIL these two, in other words, what we were just talking about, you would get this. Well, the trick with factoring is to start with what the answer is and break it apart into two linear terms. This is linear because the x only has an exponent of 1. Same thing with this. This is a quadratic, meaning that the largest degree exponent is 2, not 1. So let's go through factoring. This is also what I call a, let's start with a slightly easier one. Okay, let's factor that quadratic. Now, have we talked about factoring at all? We haven't, have we? Not yet?
No, not yet.
Okay, cool. I'll just give you this is what I call a level 1 or an elementary quadratic, the easiest kind to factor. And there's just a few steps you have to memorize. And step 1 is you separate the squared term. Okay, and that always separates into x times x. And we know that the first step of multiplying these two things back together is to multiply this term times this term, so we know it has to multiply together to give us x squared. Second step of factoring is to determine the signs. What must our signs be? Plus, we can have them both be plus, we can have them both be minus, we can have 1b plus, 1b minus. The way we determine the signs is to look at the sign on the constant term. The constant term here is 10. The sign in front of it is plus. What that means is that both of these signs have to be the same. They either have to be plus plus or minus minus.
They're going to be plus plus?
They got to be, in this case, plus plus, because after we know that they're the same, we got to look on the sign on the middle term. So these signs that are on the constant term and the middle term are extremely important for factoring. That's the first two steps. The third step is quite simple in this case, and it is we need factors of 10, meaning two numbers that multiply together to give you 10, that add, because of this plus sign, to the number 7. Well, what factors of 10 add to 7? I'll give you a little technique for factoring. Always start with the number and 1, okay? Because I know that 10 times 1 is 10. And then try to cut this in half and double that. So 5 times 2 also is 10. And I can't cut this in half anymore. In fact, 5 is prime. I can't do anything with it. So that's my only set of factors. 10 times 1 and 5 times 2. So which set am I looking for?
5 times 2.
Right. So the 5 goes there and the 2 goes there. I could also put the 2 here and the 5 there. It wouldn't matter. Okay. So that's rather straightforward. Let's look at this case. Well, the first step is the same. Split up the x's, the x squared, into x and x. Second step, what are my signs in this case? And the second step is to determine both signs, not just one. You don't want to do them one at a time. I think it's real important to go through this exact process when you're learning factoring.
Yeah. So, they're going to be two separate signs. So one's going to be negative and one's going to be positive?
No. If they were opposite signs always multiply together to give you a negative. So when I look over here at this plus sign, I know that both of my signs have to be the same. They either have to both be negative or they have to both be positive. To determine which, I look to that sign. That tells me they have to both be negative.
Yeah.
Now the third rule is still the same. The fact that this is now negative 7 doesn't really matter because my third rule was factors of 10 that add, because of this plus sign, to the number 7. Not to the number minus 7, but just to the number 7. Well, again, that's 5 and 2. Okay?
Yeah.
All right. One level harder, where that's a minus sign. Still elementary, still my level 1 quadratic, but it's getting to be a little harder because the sign in front of the constant is now negative. Well, step 1 is still x and x. Now this thing tells me that my signs have to be opposite. The only way I can create a minus 10 is if I'm multiplying a negative number times a positive number. So I can do plus minus. And in this case, plus minus is the same as minus plus. So I only have to do it one way, and it doesn't matter which way I write it. I'm just going to make sure my signs are the opposite. Now, that's only true on elementary quadratics like these. Elementary quadratic being where this never has a coefficient. In other words, this term is always just x squared. All right, now I've determined my signs, finished step 2. Step 3 is factors of 10 that don't add but subtract because of that to the number 3. Not to the minus 3, but just to the number 3. Well, again, that's 5 and 2, only now there's a step 4, because I have to know which one to put the 5 with and which one to put the 2 with. Always put the bigger number with the sign of the middle term. So the 5 has to go there because the sign on the middle term is negative. Therefore, the 2 has to go there. And now, let's check our answer. Now, in order to check our answer, you would think that, well, we just have to FOIL this thing back together again and make sure we end up with that. But the reality is we really don't have to do that much work. I could do that, but I know that my x times x is x squared. I mean, I started out splitting it up like that. I did the immediate check right after I did it. I don't need to worry. That term's not going to be wrong. Same thing with the minus 10. I did all kinds of work to find factors that add or that multiply to minus 10. So the only term I really need to worry about is this middle term. Did I get it right? Well, that middle term is produced from multiplying the inside 2 terms and the outside 2 terms and adding them together. Well, that's a plus 2x. This is a minus 5x. Add those 2 together, you get minus 3x. I did it right. Okay? So for a while at least, I would always suggest you use what I call the double smiley face method. And just always check your middle term. Okay? All right. We'll be working on factoring for a while. There's still one other major method of factoring that I need to teach you, and that's the difference of perfect squares. But we're good for today. And let's see, you're set for Tuesdays and Fridays at the same time, right?
Yes, yeah.
Yeah, let me just double check. Yeah, okay. I will. Now, I guess what I'll do on Tuesday is just call you with my cell phone or one of the phones. Instead of texting you the meeting ID, I'll just call and give it to you.
All right.
Okay? All right. Chris, I'll talk to you Tuesday. Have a good week.
You too. Thank you.
Bye-bye.